All right, now in the previous video we talked about how to choose polynomial degree if you have a model with polynomial-based features. A similar question is how much to regularize if you're regularizing a model. Remember, we choose a parameter, lambda, that determines the relative regularization of the model. Now actually this is going to be a fairly short video because it's the very same strategy. So you can, instead of choosing a range of degrees for a polynomial model, you can choose a range of lambda values. Now look at here, the lambdas are chosen geometrically, doubled each time. You don't want to choose 0.1, 0.2, 0.3 and so on, because you really don't know the order of magnitude of lambda. So you want to choose lambdas that have quite different magnitudes. After you've done this for a large range of lambda, you can home down into a smaller range. Okay. So what you do is you do the same thing here. You train for each one of these lambdas. Then you do cross-validation for each one of these lambdas. So if you had 4 folds, you would get 4 results, accuracy numbers, or measurement or measures for each one of these lambdas. You take the average to get a cross-validation score. All right? So you get a cross-validation score for each one of these values of lambda, and you'll get a similar phenomenon that you did with the polynomial model. So here, just to show the procedure one more time, for lambda equals 0, no regularization. You minimize j to get your trained model. Then you will also get a CV score, and you'll plot both of these on your graph. So you do that for each value of lambda that you're going to test. And if you get a certain value of lambda that has the lowest JCV, well, in this case, you probably should choose some other lambdas close by just to make sure your lambda is really the best, because these lambdas are quite widely spaced. But you can do a finer test on your lambda and then get the best lambda and then use that one for your model. So what happens in this case is that as you increase lambda, the training error is going to go up, because as you have increased regularization, that tends to flatten out your model. However, the cross-validation is going to go down and then up. Cross-validation will be high here for low lambda because you're basically using a lot of parameters that are not necessary. But as you increase the value of lambda, you're regularizing the model more and more. You get down to the minimum value of lambda. This is the lambda that you choose. So really, it's very, very same philosophy that you do to use polynomial degree. It's pretty much the same. So we'll just stop there. That shows that this approach of using cross-validation to preliminarily verify your model is a valuable way to compare models and select them before you do your final test. Okay, so in the next video we'll talk about training set size.